All right, section 12.4, the law of sines. So far as we've been working with sine, cosine, and tangent, we've had perfect right triangles, okay? But that's not always going to be the case. And today we're going to work with triangles that are not right triangles. All right, so we have something called the law of sines. And we use the law of sines only when we do not have right triangles. All right, so when we do not have right triangles. Now, I want you to look at this triangle that we have here. All right, angle A, or the capital A, the big A, is always across from side A, or the little a. All right, then we have angle B across from side little b, and we have angle C across from side little c. And we're going to be working with triangles like that all day today, and you'll be able to notice that right away by the end of the hour. All right, so today is all about triangles that are not right triangles, and we're all about sine today. Okay, the law of sines. It's going to be the sine of A over little a is equal to the sine of angle B all over little b is equal to the sine of angle C all over little c. And again, we're going to be using that so many times today that will be memorized by the end of today. All right, now when do we use the law of sines? First of all, you have to have a triangle that is not a right triangle. And then we have two situations. The first situation is when we know two angles and one side. And if you think back to geometry, that is either going to be angle side or angle side angle. All right, that's when we have two angles and one side. And I'll be honest with you right up front, we like those problems. When we have angle side or angle side angle, when we are given two angles, we like those. And then the other time we use the law of sines is the not so nice time. But that's when we know only one angle and two sides. Oopsie, it's only one angle and two sides. In that situation, we call side angle. All right. Let's just try example 1, and we'll put this to use. So, it says, find the length of C, so we're looking for side C, when we are given that angle A is 94 degrees, let's write that in there. Angle C is 67 degrees, and then side B, or little b, is 25. All right, now we can see that this is an example of angle, then knowing a side, then knowing an angle. So angle, side, angle. So make sure we write that down so we know that this is angle, side, angle. All right, and that's our first option up here, when we know two angles and only one side. That's the side that we like to do. Now, when we're talking about a triangle, and we know two of the angles, we can always find the third one pretty quickly, right? So the measure of angle B is going to be 180, and then all we have to do is subtract 67 and subtract 94. All right, so if we start with 180 and we subtract the angles that we do know, we should find that third angle. All right, so use your calculators. What is the measure of angle B? (19 degrees). Very good. So we can go ahead and fill that in on our triangle, that the measure of angle B is 19 degrees. All right, so now that we know all those angles, we can use the law of sines. So we're looking back up here, and I also wrote it on the board over there that you can look at once we turn this page. Sometimes it's nice to see that. All right, so we're going to use the sine of angle A, which is 94, over little a, which we don't know, so we just call it little a, is equal to the sine of angle B, which is 19, over little b, which is 25, is equal to the sine of angle C, which is 67, over little c, which we don't know. Okay. Now this is what I always do. We have your first, second, and your third piece. First, you need to find the most helpful piece. The most helpful piece has a number on the top and a number on the bottom. So in this case, the second piece is our most helpful piece because we got a number on the top and the bottom. All right. Then we need to find our second helpful piece. Now this problem is telling us to find the length of little c. So what we're going to use is the third piece because it has the little c in it. Does that make sense how we picked the two pieces we're going to use? The most helpful one has a number on top and on the bottom. And then the second one is the piece that we're looking for, which in this case is the little c. All right, now what do we do when we have a fraction equal to a fraction and we're solving for a variable? Thank you, Natasha. Nice job. We're going to cross multiply. So in this situation, we have the sine of 19 times c is equal to 25 times the sine of 67. All right, what are we solving for here? The c. We want to get the c all by itself. So we're going to divide both sides by the sine of 19. All right, then the sine of 19 divided by the sine of 19 cancels. We have c is equal to, the only way we can do this is if we use our calculator. So we have 25 times the sine of 67. Okay, then I always push equals. And that's going to be divided by the sine of 19 equals. All right, so what are we going to get for little c? What do we get for c? Everybody should have done that on their calculator. Because if we're not getting the right answer, you need to let me know because maybe your calculator isn't set right. I can fix that. It should be in degrees. Or if you're not putting parentheses around the number that you're finding the sine of, that can goof things up. So what did we get for the letter C? 70. Thank you. Thank you. 70, let's say it's about 70.7. Okay, if we're going to round that correctly, 70.7. All right, so we can fill that in on our triangle, 70.7. Now, what were we supposed to be solving for in this problem? Did we do that? Then we're done. Definitely read the directions, because if you started solving for every piece of this triangle, you'd be doing more work than you needed to. All right, let's move on to example 2. Now, the first thing I notice is that we don't have a triangle, so we have to draw one. And that's going to be the case in our homework. If we're doing a problem about a triangle, whether they draw it or not for you in the book, you need to have a triangle on your homework. All right, so this is triangle ABC. So across from big B is little b, across from big A is little a, and across from big C is little c. And we are given that angle B is 118 degrees, that angle C is 36 degrees, and that little c is 14. Okay, now every time you are given, all right, first of all, what kind of triangle is this? What are we given? Very good. An angle, and a side. So this is angle, angle, side. All right, so when we're given two angles, we can easily find that third angle. So we're going to look for the measure of angle A by taking 180 and subtracting 118 and subtracting 36. All right, so plug that into your calculator. 180 minus 118 minus 36. What's the measure of angle A going to be? 26 degrees. Great job. So we can fill that in for angle A. Okay, now we're going to use the law of sines. So it's going to be the sine of A, the sine of angle A is 26, over little a, we don't know what it is, equal to the sine of angle B, which is 118, over little b, we don't know, is equal to the sine of angle C, which is 36, over little c, which is 14. Okay, now we have our first piece, our second piece, and our third piece. First, you always look for the most helpful piece. The most helpful piece has a number on the top and the bottom. Which piece is the most helpful? The third piece. It has a 36 on the top and a 14 on the bottom. All right, then we have to look to see what do we need to solve for in this case. Are we solving for everything? Doesn't it say solve for triangle A, B, and C? All right, so we're going to be doing this twice. It doesn't matter which two we find first. Matt, which two do you want to do first? The first and the third or the second and the third? All right, so Matt says let's deal with the first one, which is the sine of 26 over A equal to the sine of 36 over 14. We have to have this one. We have to have the sine of 36 over 14 because it has both pieces, a top and a bottom. So we cross multiply. We have the sine of 26 times 14 is equal to A times the sine of 36. We're solving for A. We've got to get that variable all by itself. So we are going to divide both sides by the sine of 36. All right, so the sine of 36 divided by the sine of 36, they cancel. We get A by itself. Calculator time. Everybody's doing this. Good job. I see Tyler doing it. Yvonne, you got to type it in. Oh, you're still writing. So sorry. So the sine of 26, put that 26 in parentheses, times 14 equals, then divide that by the sine of 36 equals. Did you have a question, Nick? Yep, that's right. Yep, that's right. Now divide it by. Yep. As well. Any other questions on your calculator? All right, and then I saw a lot of people with this answer. We get A to be approximately, we're going to have to do some rounding, 10.44. All right, so we can fill that into our triangle. We know that A is 10.44. But we are not done, because for this triangle we needed to solve for everything. So what are we missing? We're missing little b. Okay. I'm going to go back and use the one that we said was the most helpful. I'm going to use the sine of 36 over 14 is equal to, and I'm going to go back and use the original one from our law of sines equation, and I'm going to use the sine of 118 over little b. And we must cross multiply again. We can't use the Pythagorean theorem because this is not a right triangle. That is a great question, though. If this was a right triangle, we can use that. But this isn't a right triangle, so we can't. All right, so we have the sine of 36 times b is equal to 14 times the sine of 118. Divide everything by the sine of 36. All right, b. Ian, are you already ahead of us? What did you get? Did you solve for B? What'd you get? Oh, I'm sorry. 21 point. Okay, 21.03. Very good. So little b is 21.03. Are we done now? Yes. We know all three angles and all three sides. All right. Before you turn the page, I just want to point something out. if you look back to the 2 times when we use the law of sines, we said when we know 2 angles on one side, it's going to be either an angle side or an angle side angle. We just did an example of both situations. Those are pretty quick and easy because you know there's only one answer. That's about to change. All right. Quick little review about CAST. C-A-S-T. All right, let's draw a coordinate plane. And CAST starts in quadrant 4 and it goes counterclockwise. All right, now this tells us when we're dealing with sine, cosine, and tangent when they're going to be positive. Now today, we're only talking about sine. All right, so when is sine going to be positive according to CAST? All right, the second quadrant, right? Because the S stands for sine, so we know that our sine is always going to be positive in the second quadrant. Where else? Very good. In the first quadrant, because the A stands for all. So the sine is also positive in quadrant 1. Now, let's think about this. If I were to make my initial side, like I always do, and I'm only going to be looking at quadrant 1 and quadrant 2 because that is where sine is positive, how many total degrees is quadrant 1 and 2? 180. So it's fair to say that from 0 degrees to 180 degrees, sine is positive. Would we agree with that? Okay, so let's write this down. We are going to have 2 values between 0 and 180. Okay, so when the angle that we're talking about, when angle theta is between 0 and 180, we're going to have 2 values that are equal to each other. Okay, so what does that mean? Let's just pick, all right, let's talk about angle theta. Let's just say that angle theta is 30 degrees. Okay, now first of all, we know that a 30-degree angle is somewhere in quadrant 1. So we know the sign is positive in quadrant 1, right? Okay, now we need to remember what we're about to write next. 180 minus theta is always going to give us the same sign. So in this situation, it would be 180 minus, our theta is 30. So what is 180 minus 30? What's 180 minus 30? 150. Okay, so look at this. This is going to be magical. If we're talking about the sine of 30 and the sine of 150, let's see what happens. All right, Morgan, what is, use that calculator, what is the sine of 30? What do you get when you go punch in sine 30? 0.5. Okay. And then let's see here. Jack, you got a calculator back there? What's the sine of 150? 0.5. So they're equal to each other, right? The sine of 30 and the sine of 150, they're both equal to 0.5. Now that's going to come into play when we have more than 2 answers or more than 2 triangles. All right, so example 3. Find 2 values of theta between 0 and 180 that satisfy the sine of theta is equal to 0.7194. Okay, so let's write that down. The sine of theta is equal to 0.7194. Now when we're talking about angles, all right, when we're talking about angles, is it helpful to have 0.7194? Is that a very helpful? That's not helpful, is it? So what we're going to do, and this is a new button on your calculator, is we're going to change this yucky decimal into an angle. All right, so we're going to change the sine of theta is equal to 0.7194 into an angle. So what we're going to do is we're going to find the inverse of sine. We're going to use the inverse of sine. So what I want you to do in your calculators is I want you to push, on my calculator this is how it works. You're going to have to figure it out for yours. You're going to find the second sine, so the inverse of sine, and then I'm going to type in that decimal, 0.7194. And I'm going to push equals. And what I get is that it's going to be, that theta is going to be equal to 46 degrees. Now, if I want to find another angle that's the same, I can take 180 minus theta, or 180 minus 46 degrees, and what do I get there? What's 180 minus 46? 134. So, let's see. What's the sine of 46? And what's the sine of 134? They're both going to be the same, right? They're both going to be 0.7194. What was that? Oh. Okay. Do you get it now, though? Okay. All right. All right, so we're going to use these two types of problems to help us with the rest of the situations that we're going to be working with today. All right, so I told you earlier that when we have a side-side angle situation, that's the more difficult situation, right? Side-side angle. And one of the reasons is because side-side angle situation may determine to have answers that are for maybe just one triangle, maybe two triangles, or in some situations, no triangle. Okay. So let's start example 4, and I think that's going to explain what we're talking about. All right, so first of all, we got to draw a triangle. And this triangle, it's not written down, but we should add this in. It's triangle PQR. So triangle PQR. Cross from big P is little p, little q, little r. All right, what's given? Big Q is 127. Little q is 63, and little p is 42. All right, so which situation do we have here? We have a side, and an angle. So this is side angle. All right, that's the first thing. No, why not, Matt? Do we have a side angle? Okay, are you good? Okay, when we have a side angle situation, you always have to recognize the angle that is given. All right, so when you have a side angle situation and the given angle is obtuse, what does that mean, obtuse? More than 90. Look at this, our given angle is more than 90. We're either going to just have one triangle, so one answer, or we're going to have no triangle. And the only time we have a no triangle is when we get an error on our calculator. An error on our calculator or a undefined, that's the only time we have a no triangle. All right, so let's start working. We don't need to find any missing angles because we only know one. So we can go right to the law of sines. So we have the sine of P this time, we don't know, big P, over little p is 42, is equal to. The sine of Q, we know that one, that's 127, over little q is 63. And we have the sine of R, we don't know that, over little r. Okay, we have the first piece, the second piece, and the third piece. Which piece is the most helpful? The middle, because we have a number on top and bottom. Then, what are we solving for? What are we looking for? The measure of angle P. All right, so we must need the first piece because that's where angle P is. And really, if you look at this, is the sign of R over R helpful? No, it has no numbers. All right, let's cross multiply. So I have the sine of big P times 63 is equal to 42 times the sine of 127. I want to get the sine of P by itself, so I'm going to divide both sides by 63. Okay, the 63s are going to cancel. And I have the sine of big P is equal to, all right, we got to plug and chug on this calculator here. 42 times the sine of 127 equals, and then divide that by 63. All right, we get a yucky decimal. What is it? 0.5324. Good job. Now, when we get the sine of angle P is equal to a yucky decimal, we don't want that. We want to change this into an angle. So we have to find the inverse of sine. All right, so on our calculators, second sine, and then we put that decimal, 0.5324 is equal to. All right, so what is the sine of P? What is P? It actually should just be, what is angle P? Nice. It's about a 32-degree angle. Look at here. The sine and the inverse of sine cancel out. So all we have is angle P. All right, so then angle P is about 32 degrees. And was that what we needed to solve for? That's all we needed to do. So we're done. Could we figure out the rest of it? Yeah, we could, but you know, we only can fit so much fun into one day. All right, let's try example 5. Now I want to go back just 1 second to an example 4. This is when it's side-side angle and the given angle is obtuse. If you get one answer, you're done. If you got an error, you'd be done. This is going to be a different situation in example 5. So draw our triangle. This is XYZ, little x, little y, little z. Big X is 62 degrees, little x is 32, and little y is 34. Okay. Now when I look at this, this is another side-side angle. Yep, sorry about that. All right, this is a side-side angle situation. When you have a side-side angle situation and the given angle is acute, okay, this is where the fun begins. When your given angle is acute, you might have one triangle, you might have two triangles, or you might have no triangles. And once again, you only have a no triangle situation if you get an error. All right, so let's get working. We have to use the law of sines. Okay, so we have the sine of x, in this case, is 62 over 32, that's little x, is equal to the sine of y, we don't know, over little y is 34, is equal to the sine of z, we don't know, over little z, we don't know. Which piece, first, second, or third, is the most helpful piece? The first one, because there's a number on top and bottom. What are we looking for? What are we solving for? Angle y. So that, the second piece, is the second piece we're going to use. Now look at the third piece. He wasn't going to be helpful anyway. So cross multiply. So we have the sine of 62 times 34 is equal to 32 times the sine of y. Divide both sides by 32. So we have the sine of y. All right, got to use that calculator. Somebody help me out here. Sine of 62 times 34. Then divide that by 32. Yeah, looking good. 0.9381. Now, do we like that answer? You didn't get that? You should have. Try it again. Did you make sure you use parentheses around 62? All right, we don't really like that, so we need to find the inverse. All right, so then we're going to get big Y, angle Y. What is the inverse sine of 0.9381? 69.9 something. So let's call that 70 degrees. All right, so we can write into our triangle that the Y is 70 degrees. But we have to wait and think. When it's a side-side angle situation and we are given an acute angle, we got one answer? Yes. Can we get two? We have to try. So we're going to take 180 minus theta. 180 minus whatever our angle is. So we're going to take 180 minus 70. What's 180 minus 70? 110 degrees. So that means that the sine of 70 is the same thing as the sine of 110. Okay, so I have another triangle here. I'm working on my two triangles here. Okay, when I have the given information of one angle being 62, a side being 34, and a side being 32, the other angle could be 70 and everything would work out nice and neat, or it could be 110 and everything would work out nice and neat. We got two triangles in this situation. Now, going back to example 4. If the given angle is obtuse, we got one and done. If it's acute, we're going to have 1, 2, or none. I'm going to show you none right now. All right, example 6 will be the last one we do. All right, let's draw our triangle. All right, this is triangle ABC. Little a, little b, little c. All right, what do we know? We know b is 5, little b is 5. Little a is 3.5, and big angle A is 51 degrees. All right, what is this? Side angle, side angle. What are we talking about here? Nice job. This is a side angle situation. And what is our given angle? Very good. Our given angle is acute. It's just a little cutie. It's a little one, less than 90 degrees. So the given angle is acute. Now, when the given angle is acute, we might have one triangle, we might have two triangles, or we might have no triangles. You just have to see how things lay out. All right, let's go ahead and use the law of sines. So we're going to take the sine of angle A, which is 51, over little a, which is 3.5, is equal to. We're going to take the sine of angle B, we don't know what that is, over little b is 5. And the sine of angle C, we don't know what that is, over little c. All right, we should know this now really quickly. What's the most helpful, useful piece? The first one. And what are we solving for? Angle B, so we want to use the second piece. And what do we do with those two things? Thank you, Curtis. You're with us today. I love it. So we're going to take the sine of 51, multiply it by 5, and that's going to be equal to 3.5 times the sine of B. Okie dokie. Let's divide by 3.5, divide by 3.5, and we get the sine of B is equal to a kind of a cute little decimal. What is it? Let's go with 1.11. Now when we're looking for the sine of an angle, is it helpful to get 1.11? No, we want to find the inverse. So let's take the inverse of sine. Now we get the b all by itself. What's the inverse of 1.11? Domain error means it's undefined. If you get something that is undefined, that means that we have no triangle. This isn't a situation where a triangle can be made. Alright, so when you have these type of numbers, you have one angle that's 51 degrees, a side that's 5, a side that's 3.5. Sorry, that doesn't work. No triangle. Okay.